close your eyes and imagine yourself adrift in an infinite sea of darkness, where the silence is so pure it feels like the universe itself is holding its breath. Around you, an endless expanse of stars glows softly, like scattered diamonds on the velvet fabric of space. Galaxies spiral gracefully in the distance, their light traveling across millions of years to reach you, carrying whispers of ancient beginnings. You feel weightless, as if the universe cradles you in its embrace, and you are no longer bound by time or place. Within this serene vastness lies a secret, a hidden structure that connects every star, every galaxy, and every atom that has ever existed. It is called the cosmic web, a majestic tapestry of filaments and nodes that binds the universe together in a dance of unimaginable proportions. Tonight, let this soothing journey guide you through the mysteries of this grand design. We will explore how the threads of the cosmos weave an intricate story of creation, stretching across the void to form the backbone of existence itself. So, take a deep breath, relax, and allow yourself to drift deeper into this mesmerizing narrative, where the infinite beauty of the universe unfolds like a dream. Where are you joining us from, and what time is it there? Let us know and settle into this cosmic adventure. Now, turning to the infinite universe, imagine a realm so vast that it stretches beyond the boundaries of human comprehension. It is a space where billions upon billions of galaxies, each home to countless stars and planets, drift through the cosmic ocean. These galaxies are not scattered randomly, but form a grand, interconnected design that speaks to the universe's hidden order. Within this immense expanse, there exists a profound mystery, the nature of dark matter and dark energy. Together, these unseen forces make up most of the universe, shaping its structure and driving its evolution in ways we are only beginning to understand. Dark matter acts like an invisible scaffolding, its gravitational pull binding galaxies together and guiding the threads of the cosmic web. Meanwhile, dark energy exerts a quiet yet powerful force, pushing the universe to expand at an ever-accelerating pace. It is within this canvas of mystery and wonder that the cosmic web reveals itself, an intricate network that connects all things. As we begin to unravel its secrets, we find not only a map of the heavens but a story of origins, patterns, and connections that echo through the very fabric of existence. Let us journey further into this awe-inspiring expanse and uncover how the cosmic web not only binds the universe, but also offers a glimpse into the profound beauty of creation itself. Now turning to the question, what is the cosmic web? Picture an enormous, interconnected structure stretching across the universe, as if the cosmos itself were woven together with strands of silk. This intricate network, known as the cosmic web, is made up of filaments composed of galaxies and dark matter, forming a breathtaking tapestry that connects all corners of the universe. These filaments are like colossal highways, guiding the movement of galaxies and matter, while shaping the very structure of the cosmos. The cosmic web is not merely a visual spectacle, it is a blueprint of the universe's origins and evolution. Scientists discovered this phenomenon by observing patterns in the distribution of galaxies and by studying the faint glow of the early universe, known as the cosmic microwave background. These discoveries revealed the delicate balance between gravity and expansion, forces that have sculpted this web-like structure since the dawn of time. Understanding the cosmic web offers profound insights into how the universe transformed from a chaotic soup of particles after the Big Bang into the ordered, majestic expanse we see today. It is within this web that the story of creation unfolds, as matter flows along these threads to form stars, galaxies, and the very fabric of existence. In unraveling the secrets of the cosmic web, we come closer to understanding the universe's origins and the forces that continue to shape it. Let us now delve deeper into this majestic web and explore the luminous threads that bind the cosmos together. Moving forward, let us delve into the silk threads of the cosmos, the filaments of the cosmic web. These are delicate yet immense structures, thin, luminous threads stretching across millions of light years. Imagine them as strands of glowing silk, intricately woven to form a vast celestial tapestry. These filaments serve as the universe's highways, guiding the constant flow of matter from the smallest particles to colossal galaxies. Within these threads lie not only galaxies but also glowing nebulae, where stars are born, and clusters of galaxies bound together by gravity's relentless pull. Each filament is a conduit, carrying gas, dark matter, and energy across the vastness of space, linking regions of the universe together in a seamless flow. These strands are the veins of the cosmos, vital channels through which the lifeblood of the universe moves and transforms. As you imagine these filaments stretching endlessly, consider their role in shaping everything we see in the night sky. They are not static, they are dynamic, constantly shifting and evolving, sculpted by the interplay of gravity and the expansion of the universe. Through their delicate yet powerful framework, they influence the formation and movement of galaxies, acting as both the scaffolding and the sculptor of the cosmos. It is within these extraordinary threads that the story of creation continues to unfold, with matter flowing along these luminous pathways to create the stars, planets, and galaxies that populate the universe. Now, let us journey further and explore the cosmic nodes, the intersections where these radiant threads converge. Now, turning to the cosmic nodes, we arrive at the intersections where the luminous filaments of the cosmic web converge. These nodes are the bustling crossroads of the universe, where the threads of matter meet and intertwine. Imagine them as glowing hubs of activity, teeming with some of the most massive structures in existence. Within these dense intersections reside colossal galaxy clusters, immense congregations of galaxies bound tightly together by the unyielding force of gravity. These clusters are not merely collections of galaxies, they are cosmic anchors, holding the surrounding filaments in place and influencing the flow of matter through the web. Their gravitational pull is so powerful that it shapes the very fabric of the cosmic web, acting like invisible hands tying the strands together. In these vibrant epicenters, galaxies collide and merge, sparking bursts of star formation and the creation of new structures. The nodes are also cradles of immense energy, emitting light and radiation that illuminate their surroundings, offering us glimpses into the incredible forces at play. As you envision these intersections, imagine them as the heartbeats of the cosmos, pumping vitality throughout the web and maintaining its intricate balance. These nodes not only anchor the web but also act as focal points for the evolution of the universe, where the drama of creation, destruction, and transformation unfolds on a cosmic scale. Let us now move forward, leaving behind these celestial crossroads to explore the galaxies themselves, the radiant jewels that adorn the filaments and shine as beacons across the vast cosmic expanse. Moving forward, our journey brings us to the galaxies, the luminous jewels delicately scattered along the filaments of the cosmic web. These brilliant formations are like celestial gemstones, each one unique in its structure and character, adorning the vast expanse of the universe. Picture them as radiant beacons of light, casting their glow across the inky darkness of space. Galaxies come in a stunning variety of shapes and sizes. Some are elegant spiraling whirlpools, their arms gracefully coiling around central cores that often house supermassive black holes. Others are massive elliptical giants, vast and rounded like cosmic pearls, their stars orbiting in seemingly random patterns. Then there are irregular galaxies, charmingly chaotic in appearance, defying symmetrical order yet equally mesmerizing in their splendor. These galaxies, regardless of their form, serve as the primary architects of light in the universe. They illuminate the cosmic web, tracing its delicate strands and revealing its intricate structure. Within them, countless stars are born, live brilliant lives, and eventually die, sometimes in spectacular bursts of energy that enrich the universe with the building blocks of new celestial wonders. Galaxies are not mere clusters of stars, they are dynamic, ever-evolving ecosystems. They collide, merge, and transform in an intricate dance that unfolds over millions or even billions of years. These interactions are not chaotic but serve as vital processes that shape the universe itself. They forge new stars, redistribute matter, and influence the formation of planets and potentially life itself. As you picture these galaxies, imagine them as both artists and masterpieces, endlessly crafting and recreating the universe's celestial canvas. Their light, traveling across unimaginable distances, carries with it the stories of their origins and evolution, allowing us to glimpse into the past and understand the grand narrative of the cosmos. Let us now continue, moving through the luminous pathways of the web, to uncover what lies in the immense darkness between these radiant clusters of galaxies. With the next phase of the journey in sight, we now turn our attention to the darkness between the luminous filaments of the cosmic web. These vast, empty regions, often referred to as cosmic voids, stretch like immense chasms across the universe. They may appear desolate, seemingly devoid of light and matter, but their role in the grand structure of the cosmos is as profound as it is mysterious. These haunting gaps are the yin to the yang of the bright, bustling galactic clusters, ensuring a delicate equilibrium that defines the architecture of the universe. Imagine these voids as the silent intervals in a cosmic symphony, the spaces that give meaning and contrast to the vibrant notes of galaxies and filaments. Within these voids, matter is sparse but not entirely absent. They contain whispers of gas and faint traces of dark matter, remnants of the universe's creation. These regions stretch across unimaginable distances, their silence offering a stark contrast to the lively intersections and luminous threads of the cosmic web. Yet, this emptiness carries a quiet significance. The voids act as cosmic buffers, their vast expanses influencing the gravitational pull and flow of matter across the web. They allow filaments and nodes to form, grow, and cluster without interference, maintaining the balance needed for galaxies to thrive. Without these voids, the intricate dance of matter that shapes the cosmos might lose its rhythm. As we drift through the stillness of these voids, it is tempting to think of them as cold, barren spaces, but their integral role in supporting the cosmic web reminds us that even the emptiest corners of the universe contribute to its beauty and complexity. And so, as we leave these colossal voids behind, let us continue onward, tracing the origins of the web itself, back to the very moment the universe began. With the next phase of the journey in sight, we delve into the origins of the cosmic web, tracing its formation back to the monumental event that marked the birth of everything, the Big Bang. Over 13 billion years ago, the universe was a singular point, unimaginably dense and hot. In a fraction of a second, it expanded rapidly, scattering particles, energy, and light in all directions. This was the dawn of time, the first heartbeat of the cosmos. In its early moments, the universe was a chaotic, glowing sea of particles, a dense mist of protons, neutrons, electrons, and photons swirling in a cosmic dance. But as it expanded and cooled, patterns began to emerge from the chaos, tiny fluctuations in density, seeded by quantum mechanics, acted as the first blueprints for the cosmic web. These denser regions, though infinitesimally small at the time, exerted stronger gravitational pulls, attracting surrounding particles and beginning the process of clumping that would shape the universe. Imagine this early universe as a brilliant, glowing fog, slowly clearing to reveal a tapestry in the making. Hydrogen and helium, the simplest and most abundant elements, began to form, creating the first building blocks of matter. Gravity, the cosmic sculptor, started its silent work, pulling matter together into dense pockets that would eventually become the nodes and filaments of the web. Over millions of years, these regions grew denser, igniting the formation of stars and galaxies, which would illuminate and define the threads of the cosmic web. The faint relic of this early era, known as the cosmic microwave background, still lingers today, offering scientists a snapshot of the universe in its infancy. It is a whisper from the past, a map of those first patterns that became the vast, interconnected structure we now know as the cosmic web. This intricate network of filaments and voids was not crafted overnight but evolved over billions of years, shaped by the relentless pull of gravity and the interplay of forces unleashed during the Big Bang. As we look back to this origin story, we see how the universe, in its earliest moments, carried within it the seeds of the grand structure we observe today. And with this foundation laid, we move forward to explore the unseen threads that bind the web together, revealing the hidden forces that sustain its delicate balance. With the next phase of the journey in sight, we turn our focus to the mysterious substance that forms the unseen backbone of the cosmic web, dark matter. Unlike the stars and galaxies that shine brightly in the night sky, dark matter is entirely invisible. It does not emit, absorb, or reflect light, making it undetectable through ordinary telescopes. Yet its presence is undeniable, revealed through its powerful gravitational influence. Imagine dark matter as the silent architect of the universe, weaving the threads of the cosmic web, holding galaxies in place and guiding their formation. Without it, the intricate structure of the universe as we know it would not exist. Scientists estimate that dark matter makes up more than 80% of all the matter in the universe. Its immense gravitational pull acts like an invisible scaffold, binding galaxies and filaments together and shaping the vast network of connections we call the cosmic web. To grasp its role, think of the galaxies as luminous ornaments hanging on an unseen framework. This framework, composed of dark matter, guides the flow of ordinary matter or baryonic matter across the filaments of the web. It is what allows galaxies to cluster together in nodes, forming the dense intersections that define the structure of the cosmos. Though invisible, its fingerprints are everywhere, from the rotation of galaxies to the bending of light around massive clusters. Scientists study these subtle effects, known as gravitational lensing, to map the otherwise unseen distribution of dark matter. These maps reveal a universe where dark matter dominates, sculpting its form over billions of years. Unraveling the secrets of dark matter is one of the greatest challenges in modern physics. What is it made of? How does it interact with ordinary matter? While the answers remain elusive, its significance in shaping the universe is clear. As we journey further, we explore the force that complements dark matter's pull, a force that stretches the universe to its limits, rewiring the cosmic web in ways we are only beginning to understand. With the next phase of the journey in sight, we turn to gravity, the invisible force that sculpts the structure of the universe with precision and power. Imagine gravity as a cosmic artist, meticulously pulling matter into intricate shapes and patterns. Its unrelenting pull binds galaxies together, anchors them within filaments, and defines the nodes where immense clusters form. Without gravity, the universe would be a scattered collection of particles, devoid of the organized complexity we see today. It is gravity that draws gas and dark matter into dense regions, igniting the birth of stars and the formation of galaxies. Over billions of years, this force sculpts the cosmic web, reinforcing the filaments and shaping the sprawling tapestry of the universe. To visualize its role, think of gravity as the weaver's loom, threading the fabric of the cosmos strand by strand. Its influence is far-reaching, extending across incomprehensible distances to guide the flow of matter through the vast emptiness of space. Even the immense voids between filaments owe their existence to gravity, as it pulls matter away from these regions, concentrating it into the luminous threads of the web. Gravity's artistry is unending, continuously refining the cosmic web as galaxies collide, merge, and evolve. Each interaction is a brushstroke in the masterpiece of the universe, adding new layers of complexity to its structure. As we marvel at the elegance of gravity's design, we begin to see how this force serves as the foundation upon which the entire cosmic web is built. Yet, this masterpiece would not be complete without another, equally mysterious force, a force that pushes against gravity's pull and shapes the universe in its own enigmatic way. Now turning to the extraordinary realm of cosmic simulations, we delve into the tools that allow us to study the universe's grand design from the comfort of Earth. Imagine being able to recreate the birth and evolution of the cosmos within a digital framework. Scientists achieve this through advanced computational models that simulate the behavior of matter and energy over billions of years. These simulations begin with the initial conditions of the universe, moments after the Big Bang, when particles and energy were distributed in a chaotic yet uniform manner. By inputting the laws of physics and the known properties of dark matter, dark energy, and ordinary matter, these models unveil how the cosmic web took shape. With each calculation, they reveal the flow of matter, the collision of galaxies, and the rise of intricate filamentary structures. These virtual universes are not just academic exercises. They offer profound insights into the real cosmos. By comparing simulation results with observations from telescopes, scientists can test our understanding of the universe and refine their theories. For instance, they can predict how galaxies cluster within filaments or how dark matter influences the formation of massive structures. Over time, these tools have grown more sophisticated, harnessing the power of supercomputers to simulate the universe with unprecedented detail. Visualizing these simulations is like watching the cosmos evolve in fast forward, witnessing the birth of stars, the growth of filaments, and the merging of galaxies in mere moments. They provide a glimpse into the immense scale and complexity of the cosmic web, helping us comprehend the forces that shaped it. As we explore the beauty of these simulations, we uncover not just the structure of the universe, but also the remarkable ingenuity of humanity in seeking to understand it. Moving forward, our journey brings us to the mysterious force of dark energy, which continues to reshape the cosmic web in ways we are only beginning to fathom. With the next phase of the journey in sight, we venture into the enigmatic realm of dark energy, a force so mysterious that it defies our everyday understanding of how the universe works. Unlike gravity, which pulls matter together, dark energy stretches space itself, pushing galaxies and filaments farther apart. To grasp its profound influence, imagine the cosmic web as a sprawling, interconnected tapestry. Over billions of years, dark energy has acted like an invisible hand, steadily pulling at its edges and loosening its threads. Discovered through the observation of distant supernovae, scientists realized that the universe's expansion isn't slowing down as they once thought, it's accelerating. This astonishing revelation pointed to the presence of dark energy, a force making up roughly 70% of the cosmos. While its exact nature remains a puzzle, its effects are unmistakable. As the cosmic web evolves, dark energy stretches the vast voids between filaments, influencing how galaxies form, cluster, and ultimately drift apart. It reshapes the universe on the grandest scales, leaving an indelible mark on its structure over time. By studying this force, researchers aim to unlock one of the most profound mysteries of existence, the ultimate fate of the cosmos. Will dark energy continue to expand the universe until the web stretches beyond recognition, or will its role change as the eons unfold? These questions keep astronomers looking ever deeper into space, probing the distant reaches of time to understand the full impact of this elusive force. As we unravel the threads of dark energy, we are reminded of how much remains to discover. Moving forward, our exploration takes us into the sheer immensity of the cosmic web itself, where its grand scale becomes a testament to the incredible vastness of the universe. Now, turning to the sheer scale of the cosmic web, we find ourselves confronted with dimensions so vast they are nearly impossible to comprehend. To put it into perspective, imagine the distance across our home galaxy, the Milky Way, a staggering 100,000 light years. Now picture this as merely a single thread in a tapestry that spans billions of light years across. The cosmic web stretches to such an extent that it connects clusters of galaxies separated by unimaginable distances, weaving them into a structure that binds the universe together. Each filament in this web, composed of galaxies, gas, and dark matter, spans lengths measured in millions of light years, and yet these filaments are only a fraction of the whole. Picture clusters of galaxies, each containing hundreds or even thousands of individual galaxies, acting as the nodal points of this massive network, and the voids between them seemingly empty, stretching across light years of emptiness. The scale is so immense that even light, traveling at a speed of 300,000 kilometers per second, takes billions of years to traverse from one edge of the web to another. Within this vastness, the cosmic web serves as the universe's grand blueprint, shaping the distribution of matter and the evolution of galaxies over billions of years. By studying this immense structure, scientists not only gain insights into the universe's grand design, but also into its past, shedding light on how structures as colossal as superclusters came to be. The scale of the cosmic web inspires a sense of awe, reminding us of the infinite complexity and grandeur of the cosmos. With this foundation of understanding, we next turn our attention to the particles of light that traverse this enormous network, illuminating its intricate design and helping us map its stunning architecture. Now turning to the particles of light that traverse the vast expanse of the cosmic web, we uncover a fascinating tool that scientists use to map this intricate structure. These particles, known as photons, are the fundamental carriers of light and cosmic radiation. Imagine them as tiny messengers traveling across billions of light years, carrying information about the universe's most distant regions. As they journey through space, photons interact with the matter they encounter, leaving behind subtle clues about the structure and composition of the cosmic web. By studying the way these particles of light are absorbed, scattered, or bent by the galaxies, gas, and dark matter within the filaments, scientists can piece together a detailed map of this immense network. Cosmic radiation, particularly the faint glow known as the cosmic microwave background, plays a pivotal role in this endeavor. This radiation, a relic from the universe's earliest moments, acts like a backlight, revealing the silhouette of the cosmic web's filaments and voids. When photons pass through the dense clusters of galaxies or the vast stretches of intergalactic gas, they undergo changes, creating patterns that researchers can detect and analyze. These patterns allow us to trace the otherwise invisible threads of dark matter, illuminating the pathways where galaxies form and evolve. Through advanced telescopes and instruments, scientists capture and decode this light, transforming it into a cosmic blueprint that charts the web's intricate design. The movement of these particles of light, journeying across billions of years, not only helps us understand the structure of the cosmic web, but also provides a glimpse into its history and evolution. This interplay of light and matter forms a bridge between the observable universe and the unseen forces shaping it. With this luminous perspective in mind, we now journey back in time to explore the first galaxies that emerged within the cosmic web, nestled like jewels in its densest regions. Now turning to the first galaxies, we journey back to a time when the universe was still in its infancy, a mere few 100 million years after the Big Bang. These early galaxies, some of the first luminous structures to emerge within the cosmic web, were cradled in the web's densest regions where gravity pulled matter together with incredible force. Picture these galaxies as tiny islands of light scattered across an otherwise vast and dark cosmic ocean. Their formation marked a pivotal moment in the universe's history as they began to illuminate the surrounding darkness with the first starlight. These young galaxies were chaotic and turbulent, composed of hot gas and stars forming at an astonishing rate. Unlike the mature galaxies we observe today, which often display graceful spirals or smooth ellipses, the first galaxies were small and irregular, shaped by frequent collisions and the relentless pull of gravity. Their intense activity and brilliant light played a crucial role in a transformative era known as cosmic reionization, a period when the universe transitioned from being opaque to transparent. The intense radiation from the first galaxies energized their surroundings, reawakening particles that had been in a neutral, dormant state since the early moments of the universe. This process not only cleared the fog of the early universe, but also set the stage for the structure and dynamics of the cosmic web as we see it today. These ancient galaxies, though faint and distant, serve as cosmic lighthouses, guiding scientists toward understanding how the universe evolved. By studying their light, which has traveled for billions of years to reach us, astronomers unravel the mysteries of galaxy formation and the origins of the vast cosmic network. With these pioneering galaxies lighting up the canvas of the universe, we now turn our gaze to the advanced observatories that allow us to study the cosmic web in ever greater detail. With the next phase of the journey in sight, we turn our attention to the advanced observatories that have unlocked the secrets of the cosmic web. Among these groundbreaking instruments is the venerable Hubble Space Telescope, which has been orbiting Earth for over 30 years, capturing breathtaking images of galaxies, nebulae, and distant corners of the universe. Its remarkable ability to peer into the past has enabled scientists to map the structure of the cosmic web by identifying the faint glow of ancient galaxies and tracing the filaments of matter that connect them. Even as Hubble continues to provide valuable insights, a new generation of exploration has begun with the James Webb Space Telescope, an engineering marvel designed to see even further and deeper into space. Positioned far beyond Earth's orbit, this telescope uses its advanced infrared capabilities to penetrate the veil of cosmic dust, revealing hidden galaxies and the intricate patterns of the Webb's structure. By studying the light from these distant objects, the James Webb Space Telescope allows us to observe the birth of stars and galaxies, offering a clearer picture of how the cosmic web has evolved over billions of years. Together, these observatories act as our cosmic time machines, helping us unravel the mysteries of the universe's architecture. Their discoveries not only expand our understanding of the web's complexity, but also inspire humanity to continue reaching for the stars. As we marvel at these achievements, Let us now explore the intricate composition of the cosmic filaments that bind this vast network together. Now, turning to the intricate anatomy of a filament, we find ourselves unraveling the delicate threads that compose the cosmic web. Filaments are the sprawling highways of the universe, vast structures that stretch across millions of light years, connecting galaxies like beads on a string. These threads consist of three primary components: gas, dark matter, and galaxies themselves. The gas, often in the form of hydrogen, serves as the raw material for star formation, slowly collapsing under gravity to ignite new celestial bodies. Dark matter, the invisible framework of the universe, forms the backbone of these filaments, exerting its gravitational influence to bind everything together. Though we cannot see it directly, we know it is there, shaping the contours of the web. The galaxies, vibrant and full of energy, are embedded within this framework like jewels in a crown. They interact with the gas and dark matter, drawing sustenance and forming clusters that further define the web's structure. Within these filaments, matter flows continuously, pulled by the relentless force of gravity, creating a dynamic environment where galaxies grow, merge, and evolve. This interplay between the gas, dark matter, and galaxies is what sustains the delicate balance of the cosmic web, ensuring its ongoing role in the drama of the universe. With a deeper understanding of these filaments, we can now turn our attention to the faint echoes of light that trace their patterns and bring their hidden structure into view. Now, turning to the faint whispers of the cosmic microwave background, we glimpse one of the most profound tools for understanding the universe. The cosmic microwave background, often referred to as the afterglow of the Big Bang, is a faint radiation that permeates all of space. It is not just a relic of the universe's fiery birth, but also a map, an imprint left on the cosmos when it was only a fraction of its current age. This radiation provides a snapshot of the universe as it existed nearly 14 billion years ago, offering clues about the distribution of matter in its earliest moments. Tiny fluctuations visible in this background, almost imperceptibly faint, reveal the seeds of the structures we see today, regions where gravity would later draw matter together, forming the filaments and nodes of the cosmic web. These slight temperature variations, measured with extraordinary precision by instruments like those aboard the Planck satellite, allow scientists to decode how the cosmic web began to take shape. By studying these patterns, researchers trace the interplay of forces like gravity and dark matter, piecing together the story of how the delicate threads of the web emerged from chaos. The cosmic microwave background is not just a window to the past, but a key to unlocking the secrets of the universe's growth and complexity. It reminds us that even the faintest echoes of light can guide us in mapping the vast, intricate tapestry of the cosmos. As we dive deeper into the web's story, let us explore how its luminous threads are illuminated by the particles of light that travel vast distances to reveal its majesty. With the next phase of the journey in sight, let us marvel at the beauty of patterns that weave the universe together. The cosmic web, with its sprawling filaments and delicate intersections, is not just a scientific wonder but a profound reminder of nature's inherent artistry. Its intricate design mirrors patterns we find much closer to home, like the branching veins of leaves, the neural networks within our own minds, or even the roots of trees stretching through soil. These similarities suggest that the universe operates on principles that resonate from the smallest scales of life to the grandest scales of existence. This echo of design hints at a profound symmetry, a universal connection bridging the vast and the minute. When we gaze at the cosmic web, we are invited to ponder whether this resemblance is purely coincidence, or if it reflects a deeper truth about the way nature organizes itself. Such symmetry is a silent testament to the elegance of the cosmos, where complexity and simplicity coexist in perfect harmony. It reminds us that the universe is not just a vast expanse of matter and energy, but a canvas of patterns, each speaking to a sense of unity and interconnectedness. As we revel in this harmony, the cosmic web becomes more than an astronomical structure. It becomes a bridge connecting us to the very essence of creation itself. Moving forward, we will uncover how the largest structures in the web, the superclusters, play a role as the giants of this interconnected masterpiece. With the next phase of the journey in sight, let us turn our attention to the immense superclusters, the true giants of the cosmic web. These colossal assemblies of galaxies reside at the intersections of filaments, forming the densely packed nodes that anchor the universe's delicate structure. Imagine clusters of galaxies, each containing billions of stars, gravitationally bound together to create a supercluster. These vast formations span hundreds of millions of light years, making them some of the largest structures ever known. Their sheer size and mass command a gravitational influence so profound that they shape the movement of galaxies across the cosmic web. Acting as gravitational lighthouses, they draw in streams of matter, guiding the steady flow of gas, stars, and dark matter along the filaments into their embrace. The gravitational pull of superclusters is not just a force, it is a sculptor, carving pathways through which galaxies are drawn like rivers toward the ocean. But within this grandeur lies another layer of interconnectedness. Superclusters do not exist in isolation. Instead, they are part of a larger, dynamic network, their gravity influencing the web as a whole, creating a rhythm that ripples through the universe. These giants are not merely structures of staggering size, but symbols of how the cosmos weaves together matter and energy into a unified masterpiece. As we continue to explore, let us uncover how the flow of matter through these vast filaments shapes the evolution of galaxies and, in turn, the universe itself. Now turning to the flow of matter along the intricate filaments of the cosmic web, we uncover a mesmerizing process that underpins the evolution of the universe. Picture streams of gas, particles, and dark matter coursing through these cosmic highways, flowing like rivers through an invisible landscape. This movement is not random but directed by the gravitational pull of the filaments and the nodes they connect. These streams carry the essential ingredients for galaxy formation, funneling matter into dense regions where it coalesces under the force of gravity. Over time, these concentrated pockets ignite with the birth of stars, forming galaxies that illuminate the web. The flow of matter is a continuous cycle of nourishment and transformation, feeding galaxies and fueling their growth while shaping their structure and dynamics. As galaxies form and evolve, their interactions with the filaments create feedback loops, star formation, supernova, and even the activity of black holes inject energy back into their surroundings, influencing the flow of gas and matter across the web. In this way, the cosmic web is not a static structure but a living, dynamic system, constantly reshaped by the movement of matter and the forces that govern it. With each filament acting as a pathway and each node as a hub, the flow of matter weaves the story of creation across millions of light years, a story that continues to unfold in the grand tapestry of the cosmos. As we move forward, let us explore how the interactions of galaxies within this vast web lead to spectacular collisions and transformations that define the universe's ever-changing nature. Moving forward, we delve into the captivating interactions of galaxies within the vast expanse of the cosmic web, where the universe reveals some of its most dramatic and transformative events. Galaxies are not isolated islands. They are dynamic entities intricately connected by the filaments of the web, constantly moving and occasionally crossing paths. When their gravitational fields draw them together, these encounters lead to spectacular collisions and mergers, reshaping the galaxies involved and redistributing matter throughout their surroundings. Imagine two galaxies on a fateful course, drawn toward each other over millions of years. As they collide, their stars may weave past one another without direct contact, but their immense gravitational forces create tidal disruptions, warping the structure of both galaxies. Gas within these galaxies compresses, igniting bursts of star formation, events often referred to as starbursts that light up the cosmos with newfound brilliance. Over time, the two galaxies may merge into a single, more massive galaxy, blending their stars, gas, and dark matter into one unified structure. These collisions are not mere acts of destruction. They are cosmic catalysts, triggering new cycles of creation and transformation. Supermassive black holes at the centers of colliding galaxies can become active during these encounters, consuming surrounding matter and emitting powerful jets of energy that influence the newly formed galaxy and its environment. Each collision leaves a lasting imprint, not only on the galaxies themselves but also on the surrounding cosmic web, as matter is flung into new configurations, enriching the intergalactic medium. These interactions are fundamental to the evolution of galaxies, molding their shapes, sizes, and internal structures, from spiral galaxies transforming into elliptical giants to irregular clusters taking on new forms. Galaxy collisions are a testament to the universe's ever-changing nature. As we peer further into these magnificent processes, let us now explore the mysterious quest to locate the universe's missing baryonic matter, hidden within the cosmic web's intricate filaments. Now turning to the enigmatic quest of uncovering the universe's missing baryonic matter, we are drawn into one of the most fascinating riddles of modern astrophysics. Baryonic matter, the ordinary matter that makes up stars, planets, and even ourselves, accounts for only a fraction of the total matter in the cosmos. Yet, even this small fraction is puzzling, as nearly half of it has remained elusive, hidden from direct observation for decades. Scientists have long theorized that this missing matter is not entirely lost, but instead resides within the sprawling filaments of the cosmic web, woven between galaxies like a hidden scaffold of the universe. Recent advancements have started to unravel this cosmic mystery. By studying the faint glow of light emitted by galaxies and quasars, researchers have detected threads of hot, diffuse gas stretching across the vast voids of space, forming bridges that connect galaxies and clusters. These nearly invisible streams of matter, composed primarily of hydrogen and helium, are thought to contain the missing baryons, filling in the gaps of our understanding. Observations using powerful telescopes have revealed glimpses of this intergalactic gas, which is heated to extreme temperatures by the gravitational forces shaping the cosmic web. This hot gasm, it's a faint signature that allows scientists to trace its structures and confirm its role in connecting galaxies. One of the most groundbreaking discoveries involved using light from distant quasars, which acts like a cosmic flashlight as it travels through space. The light interacts with the gas filaments, revealing their composition and density as it reaches our telescopes. These findings are not just about solving a mathematical puzzle. They hold profound implications for understanding how galaxies grow, how matter flows across the universe, and how the early universe transitioned into the intricate web we see today. The missing baryons, once hidden in plain sight, are now emerging as a crucial component of the cosmic web's dynamic structure. Each discovery brings us closer to a complete picture of the universe's composition, connecting the smallest particles to the grandest patterns. As we marvel at the ingenuity of these findings, let us turn to the backbone of this magnificent web, the invisible yet powerful threads of dark matter that bind it all together. Moving forward, we arrive at the profound influence of supermassive black holes, the enigmatic giants that reside at the centers of most galaxies. These colossal entities, millions to billions of times the mass of our Sun, play a far greater role in the cosmic web than their silent, light-consuming nature might suggest. While their gravitational pull binds nearby matter, their real power lies in the dramatic jets and outflows they unleash into their surroundings. As matter spirals into a supermassive black hole, immense energy is released, propelling streams of particles at nearly the speed of light. These jets can extend for thousands of light years, carrying vast amounts of energy into the filaments of the cosmic web. The result is a ripple effect that influences the distribution of gas, the cooling of matter, and even the birth of new stars. Surrounding filaments of gas are often heated and stirred by these energetic outflows, preventing them from collapsing too quickly under gravity. This regulation is crucial for galaxy formation, as it ensures a balance between the inflow of matter and the conditions needed to ignite star formation. In this way, supermassive black holes act as cosmic moderators, shaping the growth and evolution of galaxies over billions of years. Even more astonishing is their ability to communicate across vast cosmic distances. When a black hole expels energy, it creates shock waves that ripple through the intergalactic medium, influencing neighboring structures and impacting the delicate equilibrium of the cosmic web. By controlling the temperature and density of surrounding gas, these black holes play an indirect but essential role in sculpting the universe's grand design. As we explore the intricate dance between destruction and creation orchestrated by these powerful entities, it becomes clear that supermassive black holes are not merely passive components of the cosmic web. They are dynamic forces, bridging the smallest scales of quantum physics with the vast expanse of cosmic structure. And as their influence spreads across unimaginable distances, we turn our gaze to the web itself and its constant expansion, stretching the threads of the cosmos in ways that continue to reshape our understanding of the universe. With the next phase of the journey in sight, we delve into the relentless expansion of the cosmic web, a phenomenon that traces its origin back to the moment of the Big Bang. As the universe continues to grow, driven by the mysterious force of dark energy, the threads of this intricate web are stretched ever farther apart. Imagine the cosmos as an infinite fabric, with galaxies and filaments embedded within it. What began as dense regions of matter in the early universe now expands like a rising loaf of bread, with the filaments elongating and separating over time. This ceaseless stretching does not merely alter the positions of galaxies but redefines the very structure of the universe itself. The filaments, which once clung tightly together, gradually thin and elongate, while the vast voids between them continue to widen. This expansion influences the flow of matter, as galaxies and clusters are pulled along these elongated threads, sometimes merging into larger structures, like cosmic rivers converging at a delta. Yet, this growth is not uniform. Some regions evolve faster than others, with dense nodes of the web becoming gravitational hubs, anchoring nearby filaments. Meanwhile, in less populated areas, galaxies drift further apart, leaving behind emptier voids. The interplay between these regions reveals the dynamic balance within the cosmic web, where gravity and dark energy contend over time. The growing scale of this web also challenges our perspective, as light from distant objects takes longer to reach us, showing the universe not as it is now, but as it was billions of years ago. The expansion of the cosmic web is more than just a movement. It is a story of transformation, a dance of matter and energy that shapes the cosmos into ever more intricate patterns. And as we explore its boundless growth, we begin to grasp how this vast, interconnected web continues to evolve, carrying with it the secrets of our universe's past, present, and future. Now turning to an intriguing frontier of thought, we venture into the realm of the multiverse and its potential connection to the cosmic web. Imagine for a moment that the vast network of filaments and nodes, which define the structure of our universe, is not merely a singular creation but part of something far greater, a boundless multiverse. Scientists and theorists have speculated that each dense node within the cosmic web, where galaxies cluster and gravitational forces are strongest, could perhaps act as a portal or a bridge to an entirely different universe. These nodes, rich with matter and energy, might harbor the conditions necessary for such extraordinary connections to exist. Picture the cosmic web as a three-dimensional tapestry, where our universe is but one thread woven among countless others, each with its own unique laws of physics, dimensions, and even forms of life. Could these neighboring universes, hidden from our direct view, influence the growth and evolution of the web itself? While such ideas remain speculative, they invite us to rethink the boundaries of existence. Some theories suggest that the multiverse could explain why our universe is so finely tuned for life, with countless other universes existing in parallel, each varying slightly or dramatically in their properties. If true, this would mean that what we perceive as vast emptiness between the filaments of the cosmic web might actually conceal unimaginable depths of reality. These musings challenge not only our scientific understanding, but also our philosophical grasp of existence, urging us to ponder whether the cosmic web is simply a structure knitting together galaxies, or a bridge to infinity. While these concepts are far from proven, they embody humanity's ceaseless curiosity and its drive to understand the ultimate nature of reality. As we peer deeper into the web's intricate design and ponder its cosmic connections, we cannot help but wonder, if the universe is but one thread in an endless tapestry, what lies beyond the edges of our imagination? With the next phase of the journey in sight, we turn our attention to the profound question of life itself, and whether the cosmic web plays a hidden but critical role in shaping the conditions that make life possible. Imagine the immense threads of this web acting as cosmic highways, channeling matter and energy across the universe to sculpt galaxies, stars, and planets. Without this intricate lattice of filaments, it is unlikely that galaxies like our Milky Way and the planetary systems within them could have formed in the way they did. The fine balance of gravitational forces within the web ensures the stability of galaxy clusters and star systems, creating environments where life could eventually emerge. Dive deeper into this concept, and you begin to see how the cosmic web not only organizes matter, but also orchestrates the flow of essential elements like carbon, oxygen, and nitrogen, which are the very building blocks of life. These elements are forged in the hearts of stars, spread across galaxies during supernova explosions, and carried along the filaments of the web to seed new star systems. In this way, the cosmic web acts as a vast circulatory system, distributing the ingredients necessary for life throughout the universe. Could it be that the very existence of life on a planet like Earth is, in some indirect way, tied to the larger structure and dynamics of the cosmic web? While the connection may not be immediately apparent, the web's influence extends far beyond what we can see with our eyes or measure with our instruments. It is a reminder that life, as fragile and fleeting as it may seem, is part of a much greater cosmic design. This interconnectedness between the structure of the universe and the emergence of life invites us to consider our place in the cosmos with a sense of wonder. It suggests that, just as the cosmic web ties together galaxies and clusters, life, too, is an integral thread in the fabric of existence. As we reflect on this profound relationship, we are reminded that our search for understanding is not just a scientific journey, but also a deeply personal one, connecting us to the universe in ways we are only beginning to grasp. With the next phase of the journey in sight, we now turn our thoughts to the future of the cosmic web, contemplating the fate that awaits this extraordinary structure in the distant reaches of time. Will it continue to expand, stretching its intricate filaments ever further as the universe itself grows? Or could there come a time when this magnificent interconnected web begins to contract, drawn back under the influence of gravity? The answer may lie in the forces that have shaped the universe from its very inception. As it stands, the universe is expanding, with galaxies drifting apart along the threads of the web. This expansion, driven by a mysterious force known as dark energy, shows no signs of slowing. In fact, current observations suggest that dark energy is causing the expansion to accelerate, pulling the filaments of the cosmic web taut, thinning the connections between galaxies, and isolating them into lonely islands adrift in the vastness of space. If this trend continues, the cosmic web could become a more fragmented and distant network, with clusters of galaxies moving so far apart that they eventually fade from each other's view. But what if dark energy changes its behavior over time? Some theories propose that it could weaken and allow gravity to take over, reversing the expansion. In such a scenario, the filaments of the web might contract, drawing galaxies back together in a process that could culminate in a dramatic collapse of the universe itself, an event some scientists call the Big Crunch. Yet, there is also the possibility that the cosmic web will evolve in ways we have yet to imagine, shaped by forces and phenomena not yet understood. The future of the cosmic web is a mystery tied to the ultimate destiny of the universe, a question that continues to inspire scientists and dreamers alike. As we ponder these possibilities, one thing is clear: the story of the cosmic web is far from over, and its fate will remain one of the greatest puzzles of cosmology for generations to come. Now, turning to what the cosmic web tells us about ourselves, we find profound connections between the universe's grand design and the intricate patterns of our own existence. The cosmic web, with its vast, interwoven filaments, mirrors the very essence of connectivity, a principle that resonates deeply in our lives. Just as galaxies are linked across unimaginable distances, forming the threads of this universal tapestry, so too are we bound to each other and to the world around us in ways that often transcend what we can see or measure. Studying the cosmic web reminds us that we are not isolated beings, but part of a larger whole, intricately connected through relationships, communities, and the natural world. This interconnected structure reflects a shared existence, reminding us that our actions ripple outward, influencing others and the greater network of life. The beauty of the cosmic web lies not just in its scale, but in its harmony, a reminder that even amidst the vastness of space, there is unity and order. Similarly, our lives are composed of countless connections, each thread contributing to the fabric of who we are and the legacy we create. By looking outward, we gain insight into ourselves, discovering that the same forces shaping the universe, the balance between order and chaos, expansion and connection, are at play in our own journeys. This reflection invites us to find peace in our place within the cosmos, knowing that just as the cosmic web evolves, so too do we, growing and adapting as part of something far greater than ourselves. With this understanding, the cosmic web becomes more than a scientific phenomenon. It transforms into a symbol of the unity that binds all existence, a reminder of our shared story within the immense, ongoing narrative of the universe. As we bring our journey through the cosmic web to a close, let us take a moment to marvel at its breathtaking beauty and profound significance. This vast, interwoven structure is not just a map of the universe. It is a testament to the remarkable forces that shape existence itself. The cosmic web reminds us that even across the unimaginable distances of space, there is a deep and enduring connection. It encourages us to embrace the wonder of the unknown, to find comfort in the idea that we are part of something far greater than ourselves. In its intricate patterns, we see reflections of our own lives, relationships, communities, and the universal threads that bind us all together. The mysteries of the cosmos are vast, and yet they invite us to pause and reflect, to appreciate the incredible story of existence in which we are fortunate to play a part. So, as you rest your mind and drift into sleep, let the thought of this interconnected universe soothe you. Remember that, like the stars and galaxies woven into the cosmic web, you, too, are a vital part of this grand tapestry. Thank you for joining us on this serene journey through the structure of the universe. If you enjoyed this exploration, please consider supporting our channel by liking the video, subscribing, and hitting the notification bell. Sleep well, and may the cosmos inspire your dreams tonight.